Okay, good morning, ladies and gentlemen. It's time to start. But I will inform you that third presenter, Katia Poboljšaj, is not present. So actually, first two presenters can make it, if needed, a bit longer, or otherwise we will make a break because better to let it in order as it was prepared. So as a first, I want to invite here in this session mitigation measures for amphibians, reptiles, and bats. So let's say small fauna, but numerous and much more numerous than is big fauna, even until now presented a lot. And so first is Steve Bega with his presentation. So please, you can start. And I will show you also to others something about the minutes, but you can start.
Okay, perfect. Morning, everybody. I've got my notes on my screen in front of me and the microphone, so I'm going to sit down if that's okay with you. Yeah, my name is Steve Bega, and I'm a technical director at Animex International. And I want to welcome you to a presentation on how we're currently developing a wildlife fencing attachment for guardrail systems to reduce road mortality and provide habitat connectivity for reptiles and amphibians and small mammals in California. I want to just quickly thank my co-author, Alexandra Thiel, and the team at Caltrans who have and continue to put their time and energy into this project. It really, truly has been a collaborative effort. So first, who are Animex and what we do? Animex International was born from its parent ecological consultancy, Eco Support in the UK, and we specialise that focus on wildlife connectivity. For over 15 years, Animex has grown into a multidisciplinary company who focus on identifying and developing ways that we can reduce wildlife vehicle collisions and improve habitat connectivity across the world. To achieve this, we utilise our team of biologists, engineers, researchers, manufacturers, and technology experts. So we've got a whole host of team and people contributing to what we do. And we've worked on numerous projects across the world, and I'm excited to just share with you about this project in California. Who are Caltrans? And again, unfortunately, Alexandra couldn't be here today, but Caltrans is the California Department of Transportation, and their mission is to provide a safe and reliable transportation network that serves all people and respects the environment. They manage more than 50,000 miles of California's highway and freeway lanes, and you may be most familiar with them and the agency as they're currently building the Wallace-Annenberg Wildlife Crossing. So this brings us on nicely to what I'm going to talk to you about today, and that is how we've been exploring ways we can adapt guardrail systems to reduce road mortality and improve wildlife connectivity. Now, for those of you that don't know, what is a guardrail? Now, according to ChatGPT, AI seems to be a kind of common theme of this conference. A guardrail on roads is a safety barrier designed to prevent vehicles from leaving the roadway, especially in dangerous areas like curves, bridges, or steep drop-offs, and it helps to reduce the severity of accidents by absorbing impact and redirecting vehicles back onto the road. A guardrail is, first and foremost, a safety barrier. It's intended to shield motorists who may have left the roadway. They come in various shapes and sizes, as you may have seen along roadways, and this is just a typical Western guardrail system that we see very popular in the United States. Now, why do we want to adapt a guardrail for wildlife? Now, we typically work on a lot of projects where animals live in wet environments, and often when roads dissect wet environments, the guardrail is used as the primary safety barrier to prevent vehicles from entering the water. Now, the distance between the road and the water is often extremely limited, so in these areas it doesn't give much working room to install a secondary barrier or a fence to help prevent animals from getting on the road and direct them towards crossing structures. So this brings me on to the history of how we've adapted existing guardrails to help reduce wildlife vehicle collisions. We first developed and proved how the general design is an effective solution nearly 10 years ago in Sable Bayfield in Ontario, Canada. And I'll just do another quick thank you to Hope Brock and the team for sharing the information for this presentation, and also their ongoing willingness to share updates on this project. In 2015, we were approached by the Sable Bayfield Conservation Authority, who had identified a stretch of road that highlighted a risk of road mortality for listed turtle species. They wanted to install a directional wildlife barrier to keep the turtles off of the road and guide them safely through an existing wet culvert. Now, we began exploring options and ideas to help mitigate the roadkill risk and come up with a solution to guide animals safely through an existing wet culvert that just passes underneath the road here. It was quickly identified that there was little to no room to install wildlife fencing on the roadside embankment. As you can see from these Google Street Shot images, there's very little kind of road shoulder, either where there is no guardrail or where the guardrail exists. But the kind of good news from the story was that we learned as part of the ongoing discussions of the project that they were going to be installing a new guardrail system. And this is some of the drawings of the exact guardrail that they were going to be installing. So we then presented an idea that would include one of Animex's standard wildlife fencing products, and that would be slightly adapted to match the spacings of the proposed guardrail posts, and also specify kind of what type of bolts and fixings would be used. And this particular Animex product is known as AMX SP. It's made from a highly durable recycled plastic. It's widely recognized that solid barriers like this are more effective at controlling wildlife movement than transparent mesh or mesh materials, sorry, particularly for reptiles and amphibians. And here you can see the initial design drawing that was used for the initial installation proposal. And there are a couple of images from and during the installation before the bottom kind of anti-dig lip was buried. And as a note, they did not want to install the fencing in a trench like we would normally recommend to prevent any animals kind of burrowing or scouring underneath. So they opted for an anti-dig lip that was folded on top of the ground, and then this was later buried, as you will see in the following images. As you can see here, it was later covered up, and there was also adjacent cross-sections of the fencing were added that you can't see in these images, or maybe down here towards the culvert. There was some directional fencing put down to further help guide the animals towards the culvert. And another thank you to Carrie Gunson, who couldn't be here, and her team at Eco Care International, who helped provide support and education to the contractors on site, and also kindly shared these images. Carrie and the team were also responsible for the monitoring of this for 2 years. So to quickly just share some of the results from this, there were 240 turtles identified of 6 species at the culvert, which included painted turtles, snapping turtles, musk turtles, Blanding's turtles, spotted turtles, and northern map turtles as well. So a whole host of turtle species going through this. And there were also some other animals that were observed at the culvert, and this included muskrats, mice, raccoons, fish, otters, and weasels. And here's just a few images of those aforementioned turtles. Here we have a musk turtle, we have a snapping turtle, then we have a spotted turtle, and lastly, a little painted turtle. And here are just some more recent images that were shared literally last week from Hope and the team. A recent update on the project reveals that they've had some issues with washout in areas of the fence with drainage, and some of the anti-climb lips at the top have kind of become damaged, but these issues have been resolved, and the barrier, nearly 10 years on, does still remain effective. We are waiting for an update on the exact kind of recent monitoring data. So again, if you want to keep in touch after this conference, I'm happy to share any information with you when it becomes available. Now, moving on to the project in California. Now, to our surprise, the Canadian project was very, very straightforward. Our design and the proposed products did not require any kind of pre-approval before construction. Put simply, we presented our design complete with the product data sheet. We shared the costs, and the next thing we knew was that the product was ordered, the product was manufactured and shipped, then it was installed, and we were sent pictures of the animals in the culvert along with the data that I just shared you. In California, the process has been slightly more complicated, and it's this journey that we're currently on, and I'm going to share with you. My main aim as part of this is to give you a bit of a look behind the scenes, to show you the intricacies that we've needed to overcome. And I hope that some of this will be useful to anybody considering or currently working on a project where this type of solution may be a good option. So just about the project, what's the project for? The purpose of the project is to improve road safety. The project will remove the current intersection and construct a series of 3 roundabouts along a new alignment. The project is located in northern Monterey County in California. This is just east of the city of Castroville, and it's adjacent to the Elkhorn Slough, which is known to be occupied by various sensitive species. Why is there a need for mitigation for these species you can see here? The project will impact California tiger salamander, California red-legged frog, and Santa Cruz long-toed salamander in their upland habitats. And to help mitigate for these impacts, Caltrans is considering 2 new amphibian crossings and also modifying an existing non-functioning cattle crossing to improve connectivity to both the breeding and upland habitats on either side of the road. And here is a map of the project area. This is State Road 156. It's highlighted in red. It's the kind of project area, and the priority habitat I was just describing is here in blue. And here's a picture that gives you a preview of the kind of general landscape of the area. The California Department of Fish and Game considers this area to be the general upland habitat for the species that I just described. And now to show you some of the kind of proposed after images of the project. So this image on the left shows how the new intersection is going to look after construction. And the images on the right here just show examples of the important breeding habitat that the fencing and crossing structures will help to provide connectivity to and from underneath the highway. And just zooming in a little bit further, we can see the existing disused cattle tunnel here, some images there. And then also on the left-hand side, we've got the 2 newly proposed undercrossings that the wildlife barrier will be used in conjunction with. Just a kind of added note that we're not trying to funnel the whole population under the highway, because basically the salinity on the northern side of the slough is not always suitable for these species to breed. So the main goal is to just provide them access while also limiting their movement and the risk of their road mortality on the road. So should any species wish to travel, they can. So as I mentioned, in contrast to the project example I shared from Canada, this Californian project and the wildlife barrier design and approval has taken an awful lot longer. This has mainly been down to the fact that it's a brand new concept, and this has never been done in California. So we've been working with the local and the state teams just to understand exactly what needs to be considered and what we need to do to have this design approved to help control the animal movement as we described. Now, our initial conversations with Caltrans actually started almost a year ago today, in September in 2023, and they're actually still unresolved, but I will go on to that shortly. Since our first meeting, we've been through various different design submissions and feedback, as you can kind of see by this timeline. Every time we've been kind of collaboratively learning, adapting, and applying new ideas to kind of help make sure that this can be taken through to the next stage. But how did the project start? How did the conversation about adapting the guardrails begin in California? So Alexandra and I kind of had an initial conversation. She reached out to us by email, and we then looked to engage the wider Caltrans team after that. We arranged a meeting that was well attended, and representatives from all of the major departments who had a stake in the project were there, which is really great and encouraging. And it was a great opportunity for everyone to discuss their ideas, their concerns, their considerations about the project, and also allow other parties to learn about the individual requirements and ambitions of kind of each department. So to give some examples, we were able to learn about the history of the project, why we were there in the first place. We learned about the wildlife itself, the importance of the connectivity. We looked at the actual design of the roadway, understanding traffic volumes, speed limits. We explored the gradients of the slopes, understood where water moved within the area, and then also, most importantly, how much room there was either side of the barrier and the kind of wetland habitat to actually put a barrier. So we looked at the exact specification again of the guardrail for this project, and we're able to discuss initial design ideas and safety and maintenance concerns. Now, thankfully, as part of the meeting, we were able to discuss and identify and also agree on a forward plan of action. The meeting concluded that we were going to explore a barrier that would attach to the guardrail and then collaboratively work to see how we can make this happen. We did also agree a plan B, that would be to install a secondary barrier, but we were going to explore plan A until the bitter end, until we had to kind of revert back to plan B. So as part of the design, the main considerations for the design that we identified were functionality. Now, this has to work for both the wildlife and the roadway. Safety being an obvious one, but this is the biggest factor that we needed to address. How will this barrier behave if a vehicle collides with it, and what impact will it have on the existing guardrail? And then finally, maintenance. How will this be looked after? Can it be replaced easily? Will it withstand vegetation clearance? And these are all things that need to be considered, because this really needs to be installed and left alone as much as possible. Now, we were lucky that we had the previous Canadian project to work from and given a good example from, but some key aspects we looked into during the design were the material type. What material would be best to use to adapt the guardrail as a wildlife barrier? Predominantly, the effectiveness was a big concern. So following current guidelines, we recommended a solid barrier, as we had previously, as it was agreed that has been shown to reduce the risk of pacing, climbing, and entanglement compared to mesh and highly transparent materials. Realistically, the main materials for consideration were wood, metal, or plastic, and it was decided that recycled high-density polyethylene was the best choice. And this was not only for its proven historical use with the target species, but also its low cost and impressive material properties. We then looked at dimensions. How high do we need the barrier to be effective for the target species? Again, following current guidance for fence heights for amphibians, we decided on an above ground barrier height of 16 inches or 400 millimeters. This included both an anti-climb top lip. We also believed a kind of 1/16 inch or 2 millimeter thick board would be best, as this is what, again, has been previously used in Canada. It was also well-established thickness of this material used for other wildlife projects. We then proposed the barrier would be installed in sheets, again, like Canada, to match the guardrail spacing on this project. And finally, installation-wise, how would the sheets be installed? Now, we wanted this to be easy for contractors to install, to not only keep the overall project cost down, but also to ensure that ongoing maintenance was simple. And installation also plays a big part in the safety of the barrier. We've explored various options for breakaway features that will ensure the barrier remains functional day to day and will not hinder how the guardrail functions in the event of a collision. And here's a copy of the initial design that we proposed to Caltrans. If we take a look we'll take a look now just at closer aspects of this, and I'll also share a download link for this at the end should you wish to take a closer look yourselves. So from this section view, you can see that the height of the wildlife barrier attached to the back of the western guardrail system. So again, as I said, this is proposed at 16 inches or 400 millimeters above ground, and it has an additional anti-climb lip at the top and also an anti-dig lip at the bottom, which is planned to be buried 16 inches or 115 millimeters below ground, with that lip just extending out. So in contrast to the Canadian project, where we could bolt straight into wooden posts that they had there, this project will use steel H posts. We've proposed to put a pre-cut slot in each of the wildlife fencing panels that will allow easy installation, but also allow the wildlife barrier to pull away and break away in the event of a collision. We've also specified a tightness for the bolts to be installed to ensure they're not over-tightened, as again, this may hinder its functionality and breakaway prospects. The panel size and weight is also manageable. It will not require any heavy machinery to move it around on site. And the panels also fit together, they fit the regular pallet size. So if maintenance crews need to keep a bunch of these in a yard somewhere, they can be stored easily, not take much room, and you can maybe even stack some other equipment on top of them. Another safety feature we have is a score line at the bottom edge of the sheet. This will initially act as a guide to show contractors how deep the fencing should be installed, but it will also act as another breakaway feature. So in the event of a collision, the barrier will either tear away or fall down onto the ground. We've also included some standard drainage perforations within this, and we're also exploring other kind of drainage options in the particular areas where we know the water flows. And then onto the proposal. So following some initial feedback and conversations with the local project team at Caltrans, we compiled our initial design along with some supporting information, and then we submitted our proposal to Caltrans officially. Now, this is a completely new concept, as I said, and the design idea and Caltrans team, they were not entirely certain internally what the protocol was for getting something like this approved. So we were apprehensive at first as to what that process would be. But luckily, the project engineers learned that this had to be approved by what they call the Caltrans New Project Committee, and our proposal was then forwarded up the chain internally to them. Just quickly again, as again, we had concerns that the proposal would face scrutiny, basically in the absence of any crash testing data that we had. But before we considered investing considerable amounts of time and money on both sides, investing in these crash tests, we wanted to kind of see what the requirements would have been from the senior engineers, so we could kind of do what we can to meet that one step at a time. And then just kind of move on to the reviews. So to give a quick insight into the various reviews, all of the conversations realistically about this project have centered around safety, with the main focus being on ensuring that our proposed barrier will not impact the guardrail in any way, shape or form. So some of the things we've done to satisfy their requirements at this stage is sharing basic material samples, also various product data and information sheets. And we've also now enlisted some third-party help from engineers to help provide more detailed guidance on material properties and any behavioral calculations prior to actually physically doing crash testing. And what's next? So as of today, we are still waiting for a response from our third-party engineers and Caltrans to determine if we can calculate the exact braking or pull-off force imparted by the amphibian barrier on the guardrail, so that the Caltrans team could basically make an assessment themselves. We're confident that this can be done, but we just need to understand the details of the modelling and the potential costs again before we proceed to investigate and explore this. And that's it. So thank you everyone for listening to me this morning. As I said, you can scan the code there, and that will take you to a copy of the specifications that I shared. Mine and Alexandra's emails are there, but if anybody has any questions, please fire away.
Thank you very much. And first, some information for that one from for you who came later, because third presenter, Katia Poboljšaj, is not present, so we can make first two presentations a bit longer. So that's why we start, or we let a colleague a little bit more time, and also to the second colleague we will let more time. So now you have time for a question for Steve.
Hello, Steve. I'm Eva, and I'm from Sweden. With the Swedish Transport Administration. You might have mentioned this earlier because I came in a bit late.
That's okay. That's okay.
Do you have any results on the longevity of these constructions?
The longevity?
Yeah.
So the first, I gave a project example from the first project we worked on about 10 years ago, and that fencing is still installed and active. The actual product and that was been used on that has been used on multiple projects for many years beyond that, up to 15, 20 years. So we're really taking a kind of product that we've used and developed and used on other in other examples for years, but just adapting it to fit this particular purpose on the back of the guardrail. So understanding what requirements, like I was describing from a safety perspective, it was, and what we're kind of learning is everywhere it has different requirements. And it's kind of understanding, you know, what do we need to do to take something that we know works for its intended purpose, but get it to work in a particular way that we believe is going to hopefully kind of revolutionize, you know, and provide a solution that, you know, there's so many wetland habitats where guardrails are everywhere. And, you know, we're learning more and more and more about the impacts and the kind of how much these species are really struggling in these areas, but there isn't much room to work with. So if you can make something like this work, then hopefully, you know, if Caltrans as a kind of world leader in transport approves it, then we hope that might make it easier for the next one to approve it, and then it becomes a viable solution and a cheap one as well, trying to make sure things, don't cost any more than they need to.
Thank you.
Some more questions? We have a little bit time yet.
Thank you for your presentation. On internet, I saw Animex sold steel fencing and plastic of HDP, PDP, plastic fencing. Why don't you choose for the steel one?
So the steel, and this is part of the discussions, it was really cost is a factor, but then it's also the functionality on the guardrail. So during the initial questions about, what material should we use to attach this guardrail, we gave the options, we could use steel, we could use plastic as the two main ones. Straight away, the engineers were like, if we use steel, that's potentially going to hinder how the guardrail behaves quite considerably. Whereas the plastic is going to be not only cheaper, but then hopefully break away, and not hinder that barrier. I mean, I would like to explore, the steel and really what we can get to at that point, but we're kind of taking every step at a time.
Okay, some more question? If not, thank you once more. And please let's invite the second presenter, Lena Collet, who will tell us something also about assessing effectiveness of tunnels for amphibians.
Oh, good morning, everyone. Lena Collet and myself are biologists and engineer in road ecology in the National Scientific Technical Resource Center in the fields of sustainable environment in France. And our presentation is about the evaluation and monitoring of the permanent system of crossing structure for amphibian species, the famous towed tunnel. It's a study and experiment ongoing with a lot of partners in France, association and departments, and ministry, etc. So before Lena is speaking, just generality. The amphibian population, common and rare species, are endangered and threatened all over the world. And it depends of several drivers. The main habitat loss, degradation, fragmentation, invasive species such as crayfish, fishes, and disease, chytridium, Hannavirus, emergency disease, and other such as direct exploitation for food, and since some decades, climate change that affect the duration of hydro period for the breeding habitats. And road impact directly the habitats, terrestrial and aquatic habitats, by chemical impacts, modify the interspecific relations, thermal emissions, light, and the noise. We focused on directly impact such as barrier, filter to movements, the fragmentation habitats, and the killed individual by road. Slide. Thank you. Road cause a loss and degradation of habitats. Road network dense, reduce in size, suitable, isolated, good habitats for amphibians. In France, we estimated road density to 2 kilometers per kilometer square. And the direct impact, we estimated on 100-meter road sections, we estimated in one night during breeding period, during migration from terrestrial habitat to aquatic habitats, 100 to 1,000 individuals on 100 sections. So on the sites, we estimated several thousand individuals killed by road. In France, we estimated between 25 to 50 millions that are killed by road each breeding season, without counting juveniles and some other species. Yeah, slide. Since 4 decades in France, different mitigation measures are a response to this major mortality. And 2 major methods during the migration and movement seasons of amphibians are the temporary systems with a net fence and the traps by several volunteers. We estimated 500 all over the territory in France, the red points on the map. And the most well-known method is the towed tunnel, the crossing structure under the road. And we estimated 50 all over the world, the real crossing structure for amphibian species. The cost is significant. We see small underpasses to left and high underpasses at the right. So,
okay, I'll start with a small quick definitions of road underpasses for amphibians. So it's defined as it's on a defined road section of about 150 meters to 1.5 kilometers. And all of them have common principles. So it's composed of a barrier. It's an obstacle to access the roadway. And it leads to the crossing under the roadway with a certain distance between them that is about 30 to 100 meters. So we can see that it exists a large variety in terms of conception. So we can see different types of forms and sizes, and even the fences. They can be made of metal, of wood, of plastic, of different heights, but also the small equipments like the traps and the quality of the floor substrate that we can find inside the tunnel. In France, we can find 2 major types of tunnels, so the two-way types, in which the amphibian use the same tunnel for both migrations, so the prenuptial migration and the postnuptial migration. And a very different one is the one-way tunnel, and here the amphibian use one specific tunnel for the prenuptial migration and another one for the way back. So this slide is just to show that we keep building those very, very expensive crossing structures. But still today, we can see that from the literature in Europe and North America, there is still a real lack of road underpasses evaluation. And it is true, especially for species like the amphibian groups. So in France, we decided to gather informations in 6 to 8 feedback sheets. So in around 6 to 8 pages, we have an overview of the landscape context, the underpass conception, the results before and after construction where monitoring has been carried out, and also the perspective for the years ahead. So far we have about 30 feedback sheets that has been written or that are being written. And what we confirmed so far, what we conclude is that in only 1/3 of the sheets, an evaluation of the effectiveness has been done. And when it does exist, we can see that the methodology is highly heterogeneous in terms of monitoring time span, of techniques, but also human resources. And it's often concluded that it's effective for the anurans, but there are still many, many doubts that remains for the newts and the salamanders. So all the Eurodel, but also the dispersal of the juveniles. So apart from the feedback sheets, our work is based on monitoring two sites with completely different characteristics. And we use camera traps to do that. And it's in order to use the images to then work with a research institute of technology to create an algorithm that will be able to sort out the images. So it's very important to have all this information to get to a national standardized monitoring protocol. So the first site we equipped is a two-way tunnel in the northeast of France. And it has been built in 2024. So we equipped it for 2 years now, and in which the protocol has evolved in terms of the placement of the cameras, the time between two pictures, etc. So this year we decided to place one camera on the ceiling like this with small fences to direct the animal under the camera. And we kept one camera that takes the exits of the tunnel, but it was mainly to compare the results we obtain between the two cameras. And when we install this, we ask ourselves the question, how can we put the camera so that we can put it in the same way in all different types of tunnels? So this is what we done in a second tunnel, this time in the southeast of France, and this time in a one-way tunnel. So we can see here the tunnel is completely different. It has a size of 40 centimeters square, so it's very little. So it was difficult for us to just put the camera on the ceiling facing the floor. So what we decided to do is we find the compromise to put it at the entrance in the pit, so where the animal fall here before crossing the tunnel. It was much easier to have the same data than the other type of tunnel and to get the camera out and in. And then we still, we built a little trolley to put around 2 or 3 meters inside the tunnel to have the results of the animal coming towards the exit. The parameters were the same for the two sites. So we took one image every 13 seconds between 8 p.m. and 8 a.m. And we were going on the field every 4 days to change the rechargeable batteries and the SD card. So here's some images we obtained from the camera traps, and our real challenge here is to find a compromise between the high cost and the time consuming, but also the usable results. So how many images do we need to obtain to be able to prove that it was actually effective? Because one camera trap pack is over €100. And it's very time consuming between the field sessions where we have to go every 4 days maximum and the image sorting, because one camera trap each day generates about 3,000 images, which means that we have more than 1 million images in just one season monitoring and in only one camera trap. And what we want to show with this monitoring, so we put the priority on the prenuptial migration. We want to have a qualitative result, so what species or group of species use the underpass, a qualitative result, and what interests us, it's also to have a long-term studies. So this is where we work with the Georgia Technology Institute. We have a partnership of 2 years, so we started this year and it's going next year as well. And it will be master students that will work with all kinds of images to elaborate an algorithm with objectives. So we cannot really see, but the priority objectives is to sort out the empty images from the images with an individual, and that will remove like 90% of images, even sometimes more. Then the second objective will be maybe to identify the group of species or even the species if it's possible. And it's much more difficult, but we have a third objective that would be to evaluate the direction of amphibians in the two-way tunnels. So to do that, we first had to create images with a very good camera to create high resolution images under very good light condition. To do that, we acquired some real size figurines of various species of amphibians. And we took all kinds of pictures, so in many positions, under very good quality conditions. So that was the first job we did. The second one is to use the same type of figurines, but this time under real conditions. So to do that, we built tunnels that replicates the tunnels we can find in the field. So the two-way tunnel, but also the one-way tunnel. And we just did like a whole series of images in all kinds of positions as well. And the work of the students will be to crop the images and they label them. And the final job that will be quite determining will be for us to use the real images we obtained from the monitoring we did so far, and to label the images with the species or at least the group of species. One challenge we have in this work is to create the algorithm that will be able to spot any individuals in any type of substrates. And it's difficult because we have all kind of different substrates in all kind of tunnels. So for example, the newt here is on a humid floor, and we can see the reflection light of the camera trap, so it's not that visible. So what we did the same job than with the figurines. Very simple. We just use all type of substrates we can find in the tunnel, and we create the pictures the same way we did with the real size animals. So I guess as a conclusion, what we can say is that we want to expand this work to a way larger scale. So we actually work on road underpasses and specifically the tunnels, but we know today that of course we have to complete this work with road mortality monitoring, for example, and study the behavior on the fences, and maybe use acoustic enrichments, especially for newts. And we also want to have a more modeling approach using the landscape scale. That's it. Thank you.
Okay, thank you. It was very interesting. So do you have some questions? So please, let's ask them.
Morning. Maas, Belgium. I was wondering, you were checking how to monitor amphibians. That's the goal, AI based. But isn't it the difference? You have one-way and two-way tunnels, but you have also substrates, no substrates, maybe concrete tunnels, plastic tunnels, I don't know. Isn't it more useful for the amphibians to point out what kind of tunnel is best for what kind of species, frogs, salamanders, where to place them, and not only how to monitor them, but what does the monitoring give as a result? What kind of tunnel is the best for this kind of species?
I think a few studies shown that Sometimes subtract is better to have a substrate, sometimes it's not. I think it's quite controversial, so it's difficult to know what's best. And I think depending on the weather and the type of landscape that you have around the tunnel, it's difficult to just know what type of substrate you will have the whole year, and it's difficult to maintain it the whole time of the migration. So I guess that's why we do that.
Use microphone because otherwise it's not recorded and they want to be recorded.
It depends also of the species for the substrate. Toad has no problem to cross a different type of substrate in the tunnel. For the newts, or it's different.
Yes, there is more question in the back.
Hello, Laura Cliveno, railway manager, French railway manager. Did you work only on roads or also on rails? And if not, why? Maybe it can be interesting to compare.
Yeah. I forgot to say it at the end, but yeah, we are planning to work on wall rails as well. But we have very few data on that actually. When small underpass exist on the railways, we are fighting quite hard to have the data of monitoring when it has been done or. Yes.
Tonya, you had quite a lot this monitoring equipment in the tunnels. The passage was quite narrow. Did you had some problems if some larger animals like foxes or badgers tried to pass the tunnel and disturb this equipment?
You mean the small ones of
Yeah.
Otis?
Yeah.
Actually, the way the tunnel is made, it's mostly very small animals that are going through. It's like a small pit, so we didn't have any issues of like bigger animals that were going through the trolleys. And yeah, we had more issues with the substrates actually. To get like the trolley inside and outside was more difficult.
Okay, I will also give you one question because for me it's very, very interesting that you have two types of tunnels, one way and both way. Like usually we have just tunnel and we expect that animals are really moving there and back, same tunnel. So for me it's interesting why to build two tunnels next to each other for different directions.
One of the response is commercial conception, but sometimes one of the type of conception is more adapted to the topography. It depends, but in France we have an influence of an enterprise, a Switzerland enterprise, and on German enterprise in the region.
Hi, Steve from the UK. It's more of perhaps a conversation for after, but I'm just intrigued by you mentioning acoustic enrichment at the end, because I've never heard of that being used for frogs in this context. So are you able to share some work that's been done on that previously, or share ideas of how you plan to do that?
Yeah, work has been done on that. Guillaume Testude, I don't know if you heard of him. Yeah, so they actually place the playing frog calls at the exit of the tunnels, and newts that are not working with sound, with smell, they are actually following the sounds of neurons, so of frogs. and it's actually it's working.
That's really interesting. Thank you.
Yes, Sergey Bogas from Netherlands. I always see a focus on migration in the spring. So like the adults going to the ponds. But of course, the second migration, the juveniles and adults coming back from the ponds, is also very important. Is it possible to monitor juveniles as well in this system?
Very, very few studies has done that because it's very difficult because the dispersal is huge. So even if we have some data, it's difficult to know what the other individuals are, like where they are going. So we would like to do it in the future, but yeah, it's a wish, but we don't know if it's that easy. So actually, yeah, we focus on that, but of course the post-nuptial migration is that important.
I just wanted, Marguerite from Switzerland, I just want to add some information about the one-way and two-way tunnels. It's a question of generation. So the first tunnels were these two-way tunnels because the idea was to force the amphibians on the other side, and it was just spring migration. But the monitoring has showed that this is not good for the autumn migration for the juveniles. And so, for instance, this is no longer used in Switzerland. It's been it's so, but you know, you learn, you try things and you learn. Yeah.
Marguerite, just a response, quickly a response to Marguerite. In France, the tooth tunnel exists, and we have the obligation to evaluate this type of tunnel, one way, double way. And actually, sometimes in Isère, in department of Isère, we continue to create this type of tunnel. And for myself, it's difficult to choose because sometimes the two type have good quality. It depends on topography to migrate. It's difficult. In the guidelines, we propose a unique system today, but it's complicated to.
Maybe a last question in the back.
Two. First question, how did you choose the tunnels you wanted to study? And did you study the tunnels not dedicated to amphibians, and in particular those connecting to stormwater ponds on either side of the road? And just a remark, if you want data on tunnels and rails, you can call us.
Thank you. So yeah, to reply the first question, we based on like we search for the results from the previous years, like before the building, before the construction, and they when they use netting fences and they were getting the temporary barriers. Sorry, when they use that, we just looked at the most at the most important effectives, like when they had more crossings in near this tunnel, we use this one, and same for the other ones. Yeah, but it was a compromise to find because we couldn't have all tunnels equipped. Of course, that's the goal for the years ahead, but yeah. And the second question, sorry, what was that?
The tunnels that that connecting stormwater ponds in water with water.
Tunnels with water.
With water. Yeah.
Did we study it? It's
yes,
the question.
Tunnel with water and that connecting stormwater ponds there, because there is many amphibians on stormwater ponds, highways or road stormwater ponds. So did you study those? Okay. Yeah.
Yeah, we just have some leaflets of our company in English, if you're interested in, and some articles. It's in French, but if you translate it, it has some, like, it's quite what we explained so far, but a little bit more detailed and nice images if you want to take it.
Okay.
Thank you.
Thank you very much. Evidently, it was very interesting because so many questions. So thank you once more. And now, because, yeah. And now, because Katia Poboljšaj is not present, so it's coming my for present. Okay, good noon, ladies and gentlemen. Now in different position. So my name is Krása and I work in Czech Nature Conservation Agency. I work in local branch in South Moravia, in Moravian Karst, but somehow I'm responsible for database of all these road collision sections in all Czechia. So I will tell you something about what we are doing or how is situation in our small country in Central Europe. Okay, I start with that amphibians are most numerous. It was also in first presentation that really the amount, or in a second, how many of them are killed every year. There are much more dead bodies than the big fauna, but so they are strongly affected and sometimes to local extinctions. I think that all of you know the situation, and somehow they should be priority goals to solve, but in mostly or usually they are not, because big fauna is much more popular, and frogs for someone a strange animal somewhere on the ground, and why should we care in something? So we should care. And I put there this case of what happened in China, because like thoughts, what do they for us? Why we need them, and why not lose them? Yeah, okay. You all probably know that in 60s in China, Mao and his followers decide, sparrows are eating our grains, so let's to kill sparrows, and we will have more grains, and our population, our society will be better because more food and better health and everything. For something like 4 days, they made a big noise all over China, and they were really successful. They killed a lot of sparrows and all other small birds. And as a result, about 30 million people died in coming years, because of course sparrows are not eating only wheat and grains, but they are eating a lot of insects, and they didn't know. So this is maybe one of the reasons why to care about frogs. In our language, frogs and toads are, we have one word, so let's care about toads and frogs, because they are doing something for us what is necessary. So we really need them even if it is not so visible as in some other cases. So why that? Oh, because of that, I put that pictures. But I start with data. Yeah, our agency is really good in collecting data about everything, what is growing, living, flying, swimming in our country. And you will see some numbers which were actual to yesterday. I put it there, and it means, so you see we have like 35 million info about all these creatures, and almost 500,000 about herpetofauna, almost or more than 300 about 1,000 of amphibians. What is important, of course, the numbers doesn't mean that we have 62,000 data about dead buffos, but it's about all buffos of country, and actually dead animals are a big portion of this. And for information, so we collect many important information. So of course, date can be exact, can be period, can be year, status. It's important in some really endangered species because our database mostly is visible to all public today, but with few exceptions, because in some species, of course, we don't want to put it precise. Mostly it's not problem in herpetofauna so much. Okay, in some Anis longissimus little bit, but for example, in orchids or some other plants, it's really crucial that sometimes people find it on the database, go to the place and can dig it and destroy it. So because of that, author of data can put it as a hidden. And locality, okay, sometimes today it's easy to go and put exact position where you find animal, plant, and or whatever. But in past, it was written, okay, in the village, name this, I found something. So all the data are not so exact as today. For example, abundance, once more, you can count if you find 3 of something, but or hundreds of something. Of course, different situation, it has different meaning and stage and whatever. What is important that our data are evaluated by experts, because of course we took data from wild public or so, and sometimes it's necessary to evaluate it because people, you know, they see something, many times they do not take picture and they say, all right, okay, it was this animal, it was this plant. And expert can say, it's definitely mistake and something. So we have kind of actually 2 stages evaluation. What is important? It doesn't mean that 100% of data is without mistakes, of course, but we are trying to get as good as possible in this situation. And the map showing distribution of, I think it was Bombina all around Czech Republic, of all localities where it was found in the past. And what is important sources of our data, of course, several different extensive mapping, for example, some direct researches or monitoring of case species or reserves and other important localities. On the other hand, also citizen science data, which should be evaluated and whatever. And also road mortality surveys, because now we are here in this section. And our agency create mobile application biolog, so you can nicely collect data in a field, what is helpful. And one important information, of course, our agency, what is good, that our database connecting all databases of groups like entomologists, botanists, entomologists, and we are exchanging data with them. So our database is good in that on one spot, you can find everything, but of course, still there are existing databases. And for example, 1 or 2 times a year, we are exchanging data with them. And yes, one more thing that, for example, we know that some areas, we have not enough data. Even there are local areas where, for example, in many square kilometers, we had no data. So colleagues, they tried to prepare project white spots or white areas. So like they create map with these white spots and push us a little bit to go there to check, to look around and to put something at least, because everywhere something is growing, everywhere something is living. So usually if we have not enough data from some area, we go there and orient on that. And Vašek Hlavač in the morning told you that there are 21 species of amphibians living in Czech Republic and 11 or 12 reptiles. So there are a few of them, the species which are the most affected by the road mortality in our country. And why they are so affected? Because many of them, especially Bufo, Rana temporaria, and also Lysotriton vulgaris, are really widespread. They are living all over country. Of course, not every 1 meter, but as you see, almost all mapping square. So let's say everywhere. And on the other map, there is the network of our roads. And also Vašek told you that there's about 50,000 bigger roads in our country. But if you go to smaller, hardly you will find areas of few square kilometers without any road. And you know, in amphibians road mortality especially, it doesn't matter, like not only highways, not only first grade roads are important, but also the field roads are important. And now, so because we have data and because for decades we see problems, yeah, already my colleagues in 80s, in 90s, they create some database of this road collision sections. They put it into some book and it was accessible for us, for followers, but actually it was actual in 80s or 90s. But you know, that situation changed strongly, and especially in our country, which was part of communist bloc. And for example, in 80s yet, we had not so many cars and the frequency of moving wasn't so big as is today. It grew up very fast. And so also the number of collision or road collision sections grew up a lot. And also the status of each road collision section is changing during the years, because some are getting worse, some are getting better. So changing sometimes every year, sometimes in 5 years. So we decide, of course, to make it more actual and try to concentrate what is happening, what is going on. So we have two tools how to show to the public. One is called Mapomat and other is our National Conservation Agency Map Gallery, where you can find not only the big map, but you can go to the more details and you see how the road section looks. And once more, when it's green, it's good, it's secured, and orange is or red one is critical, orange is hazardous or risky and showing the magnitude of problem. And of course, you see, if I put also some pictures showing that some localities, the protection is good and somewhere it was built, but already deteriorated and not so good anymore. And we are collecting data, especially for this road collision section database. So usually magnitude, because it doesn't matter if we found there 1,245 or 89 animals. Of course, we put it somewhere, but magnitude is much more important. Some mitigation measures, efficiency, of course, very important, but we cannot do it exactly. So it's kind of estimate. If you go to the road section in the spring and if you see that barriers, that temporary barriers are built, and usually, of course, or every time you will find some dead animals, because we are not able to save every animal. We are able to really put it down, but always there are something. But if it's working, if we save more than 90% of animals, it's good. It's very good. Okay, later we can discuss if 90 is enough or 95, but let's say 90 is enough. And once more, there is regular evaluation and database update. Because, for example, if we have critical and risky or hazardous road section, you should go there every year to check the situation. If still situation is so bad. And if, for example, it's marginal, okay, you can go there in every 5 years because it's not so important. Because in the spring, everywhere you will find 30, 40, 50 killed buffos or ranas. And so we are not able to care about every animals. I will put, I will jump back. And also map is showing that they are not distributed evenly around the country. Of course, it's showing that, for example, here is Brno city, second biggest city, concentrate around, also around the Prague, showing more people looking around. So we have more information. And in some part where population density is not so huge, doesn't mean that there are not problems, only showing that we don't know about the problem yet. And this is about some road section evaluation about that, how we try to evaluate it here based on the number of migrating animals, killed animals, measure or efficiency of the measures. So showing the pictures. And of course, if there is nothing anymore, so it's that last group, which is not there anymore. And now going to some, let's say, deeper or closer to some existing problems and what we are doing. Of course, the permanent barriers are very good if they are tunnels and allowing animals not only going to the road, but also connecting one side of the road with the other. And so, for example, for me, it was strange information about that one side tunnels, because usually we make barriers on both sides of the road. So animals can really or are forced to enter it from both sides, same like, yeah. And you see that we did some checking or evaluation of this road section with permanent barriers in 2016. And at that time I visited 20 localities, and half of them was in good conditions, usually made out of some concrete, some beton particles. And on the other hand, there were 5 or so 1/4 of them in really problematic status, mostly because they were rotten already and destroyed by the weather, by the non-function and something like that. So, and what is problem that only few were built since? That's problem. We are very slow. We are good in collecting data. We are good in evaluation, but we are very slow in building everything. In our country, to build anything lasts like not 5, but 10 or 20 years. And this is not exact. This is not exception. And there is one, let's say, an interesting question. Mercedes or Trabant? The one who are too young or much younger than me probably do not know what is Trabant. So Trabant was car produced in Eastern Germany in communist world, and it was used, and still it was working, but of course it's not as good as Mercedes. And it put a question, like, we need more solved road section with barriers and tunnels. But what is better? To build one really good, or 10 maybe not so good. And for example, in last weeks, we had a strong discussion with colleagues in our agency and other experts in Czechia, because it's really problematic, yes? And on the end, for example, it's about how high to build barriers. If 70 centimeters or 40 is enough. And it's something question, okay, new roads or existing collision sections, because you are solving with the different problems. And for example, road sections where mostly buffo or rana temporaria are moving 95%, this number is enough. But colleague says that, yeah, no, we need Mercedes. We need 70 centimeters because rana dalmatin but Rana dalmatina is spreading everywhere. It's maybe only one species of amphibians in Czechia, which is really population is growing up so fast and it's moving everywhere. 20 years ago, it was not present in most of the country, but today it's almost everywhere. So is it necessary to care about Rana dalmatina? I think no. Yeah, and we found problem with the newts. Okay, newts are also, this especially Lysotriton vulgaris, is present everywhere. But when people built that temporary barriers, they didn't find them, catch them on most localities. And wow, because they are small, but mostly because we found they start their activity, let's say 1 month or 6 weeks earlier than toads and ranas. Something we didn't expect it. Last year, I went with my colleague, my boss, to that locality, show him that it's problematic road section for buffos and bombinas and pelobates. And we look on the road and I found something strange. And when we look closer, we found these killed newts. There were 50 of them, and it was 25th February. What is in our Czech country, like usually they start to move the toads and frogs on the end of March. And now we found them. Yeah, so what will we do? We are not sure yet. And of course, there's big problem with climate change in Czechia because weather is changing significantly. There you see how temperature grew up in last 50 years. It's about 2 degrees, and it's causing a lot of problems because, for example, really this year season starts 3 weeks earlier than normally, but sometimes starts normal time. Yeah, it's changing year to year. 10 years ago, it was clear where to start building barriers, but today it's not clear anyway. And not only beginning of the starting, but also the weather. It's much drier. Sometimes, for example, temperature is not growing up steadily and they didn't start moving steadily, but it's 3 days, it's above 0, 3 days below 0, above 0, below 0, above. So they start, stop. And much drier without rain, much more wind. So really many more problems we are facing. And some more questions on the end. So disappear, on many localities, amphibians disappear despite our activities. And we don't know about the effect of rail or roads on our populations. And we have 10,000 kilometers, something like that. And question we have, not if one way or two way, but wet tunnels or dry tunnels. Because I heard several years ago in Lyon, there was information that if there is water in the middle of tunnel, it's much better because it's reflecting light and helping them moving. And I saw that toads are moving through the water sometimes, but some colleagues say, no, it must be dry. Question, and are buckets safe or not? Because someone started campaign 10 years ago that, if different species mix in one bucket, they poison us each other and it's so horrible. So we cannot mix them because we destroy the population. But, still when they are somehow stressed, mixed in buckets, still they have chance to reproduce later when we put them into water. Because when we let them go across the road, they are they are killed. So still better, but. And what about unpaved roads? Yeah, I mentioned, and one tractor going somewhere slowly, but toads are waiting there. Hundreds of them can be killed. But a good example on the very end, for example, this year, we not only built some barriers on problematic road sections, but we also were able to stop traffic completely on some road, which there is green, because the village was connected by 2 roads. So we asked police and other departments, and they put, so for 2 weeks, the road was inaccessible, and we saved hundreds of thousands of toads. So it was very good. And that's all from me. Thank you for your attention. And I am sorry, I was a bit, it took me a long time. So maybe one question and others can ask me later in the, if you have one question. Oh, okay, later for the later. And now I will invite another colleague to come. Sorry. Please let me advance Markus Elfström with his presentation. Switch.
Oh, thank you, everyone. So I will give a talk about monitoring we have done in Sweden, where we claim to have kind of a success in reptile recovery after creation of a wildlife-designed overpass. This monitoring program was financed by the Swedish Transportation Administration, which is also where my co-author was situated, Mats Lindqvist. So in western part of Sweden, south of Gothenburg, there was a wildlife-designed overpass, which some of you also refer to as a ecoduct constructed. And we had a whole range of impact that we tried to monitor. It's a big team included here. Measuring impact after the ecoduct construction on plant community, on wasp occurrence, bat activity, and large mammals. And what I will try to focus here on is reptile occurrence. So before constructing the overpass, all reptiles in the area were caught and captured and then sealed off from the area with solid screens in order to protect them during construction. So on the western side, to the left here in the picture, we did find smooth snake and sand lizards, and they were all so protected during construction. And then in 2018, during April, May, they were all released back in the same area, western side of the highway, and were able to start using the overpass. So we placed 80 artificial cover objects along in a transects parallel with the highway for inventory of reptile occurrence. So in these cover objects were simply plywood cover boards in order to have a systematic evaluation of monitoring of reptile. And so some of these cover boards, they were placed in very open grounds. Others with quite a dense overstory vegetation or understory vegetation. And quite often we found ants and their eggs taking shelter underneath these cover boards. And we also had quite often different rodents using these cover boards for cover. So the focal species here we had was sand lizard, and here you see examples of male and female, and smooth snake, which we from the beginning we found on the western side of the highway. And also we observed a slow worm, grass snake, and a viviparous lizard. There is also and one additional species of snakes in Sweden, the viper, which we did not find during this monitoring period. We did have one observation during construction of the overdrive. That was the only thing. So we created generalized linear mixed effect models with a negative binomial distribution in order to model the variation in reptile occurrence. So we analyzed the reptile accounts in relation to the highway surroundings and on the actual fauna overpass. And so we controlled for percent vegetation cover, degree of shadiness, ambient temperature, and ambient temperature that was varying only among the day of visits for observing reptiles. However, the other control measures were for each coverboards. And we included the identity for each coverboard as a random effect in our models. So we had 275 reptile occurrences based on over 4,500 observations. And it turned out that, so this model here is separating between reptile occurrence from the west side and east side and on the overpass. And this model turns out to be, lacked any model support in our model selection. I ran 5 different candidate models, and this is a very low support. So the trends have been fairly similar when combining. I'm sorry, and I should say that. So what I did here, I combined all the different species into one modeling, because when trying to separate per species, I ran into model assumptions violations. However, it was not related to zero inflation, but there was an issue with that. So I had to be satisfied with only look at all reptile species combined. So I did not find any support for this model with separating reptile occurrences between the reference sites on either side of the highway and the overpass. So this instead lends support for what we call the connectivity hypothesis, that variation in reptile counts was best explained without discriminating between west or eastern side or on the overpass. However, what we did see is that reptile counts was higher with a lower degree of shadiness. So open areas seems for sure to be favored by reptiles, probably due to generating higher ambient temperature. And on top of this, we would recommend try to mimic the surroundings where you originally find these reptiles, and such as also introduce shelter with rocks and wood along overpasses. However, I'm not saying that the whole ecoduct should be an open area with a very low degree of shadiness. We do know that will not favor other species, and we have not built this overpass only for reptiles. When we look for bat activity, we could see that we couldn't see any actual bat activity at all using this overpass. Bats instead used a quite narrow tunnel underneath this highway, 500 meters south. And I'm sure Johnny will tell you more about bats after me here. And when we look at large mammals and wildlife, we can see that this aqueduct works pretty good. We can see that the crossing probability is fairly similar with other aqueducts in Sweden for fallow deer. For roe deer, we could see it was a slight lower crossing probability, but I'm sure that has nothing to do with this aqueduct in design and substrate. Okay, I'll stop there. Thank you.
Okay, thank you very much. And we have time for one question.
You mentioned using the cover boards, but didn't you realize that some of the reptile species actually are not in favor of these cover boards? I mean, you can monitor the coronella with it, but the sand lizard won't go under it. We'll only use it for sunbathing. Or a grass snake, it probably won't use it. So how did you make a difference between using the cover boards and just normal habitat, which they normally use to be sunbathing or be active or?
So we had quite a few observations in between our cover boards, not on them. And however, they were not included in the models. In order to make it systematic, we wanted to, because we're using all these transits and everything to, in the end, when modeling, to see where can I capture most of the variation in reptile occurrence. However, so I agree with you that we have sand lizards not using the cover boards, but we also have multiple occasions they were underneath these cover boards, and also smooth snake and common snake.
Yeah.
So for sure they use it. And I would say maybe one bigger concern I would say is the most common mammal on this overpass is people. And people can, tramp on them and also move. We had issues with people, and they were removing the cover boards even for some reasons.
Okay, thank you very much. More questions later. And now I will invite the Johnny de Jong, for his presentation.
Okay, so finally some bats. How nice. I'm working as a researcher at the Swedish Biodiversity Center, and this study was done together with Adina Sennblad and Isabella Honner. So I will talk about pipe culverts. As you all know, infrastructure is a real problem for bat species. The direct impact is habitat loss, of course, but then we have also cumulative effects. We have barriers leading to connectivity loss, and we have light, noise, and collisions. And you also know that there are differences between the species, and there are also differences during the year. Now, in this presentation, I will concentrate on barriers and connectivity loss. And you will hear more about noise after me, I think, I hope. So when we talk about barrier effects and connectivity loss, it's mainly relevant for these forest living species or the clutter adapted bats. They spend most of their time within the forest or in the forest edge. And especially during the light part of the year, June and July, they are really much within the forest and avoid open areas. In Sweden, we have about 10 species of forest living bats. However, I also want to mention this group because we have the bats foraging in the open air as well. And with this, we have completely different problems because they can easily cross the road, but then they are exposed for collisions instead. So that's another problem. Some years ago, if you are working with bats, I'm sure you have seen this paper. Some years ago, this was produced where they compared two species, one forest living bat, Myotis becksteini, and one foraging in the open space, barbastel. It was completely different problems. And now, last week, I was at the bat conference in Tarragona, the European bat conference, and they presented again papers on the problems with barbastel. And they have studied the barbastel and found that 51% they were crossing the roads at height lower than 5 meters. And that means that they was at least very exposed for larger vehicles. So for these species foraging in the open area, maybe the problem is even bigger. But now I turn back to the forest living species and the mitigation possibilities for them, because with these species, we actually have some possibilities. This is one example, an overpass, which I have been studying. And we have underpasses, and we have smaller underpasses like these pipe culverts. And as I said, I have the opportunities to study this overpass, and I presented that before. This was some years ago. And in this study, we found one colony of Meiotis mestacinus north of the structure, and one colony of Meiotis branti south of this structure. And we could follow them with radio tracking, and we could see that they were actually following the road, and they were foraging in the forest south and north of the road, and they crossed the road at the wildlife passage and also under the road, but they never crossed the road in this open space. And additionally, I studied this motorway with automatic recordings at many different positions, both along the road, in control sites, and in other open areas. And the result was very obvious. I could see that brown bat and the whiskered bat, they actually avoided this big road, and I have no records of bats crossing the road. Of course, they do sometimes, they must do, but not during this time of year in this area. This was during the time of the pregnancy and lactation, when the female formed the colonies in June and July. But we could also see that this wildlife passage actually works very well. They might work very well, at least. In this case, they was very efficient, both above and under the road. However, as you all know, this is quite expensive structures. It's quite complicated, and in some cases it's impossible, depending on the landscape structure. So it's not a good solution everywhere. So therefore, we decided to continue and study these smaller pipe culverts instead, to see if that could be a solution. So the question we had was, are these small pipe culverts efficient as mitigation methods to increase connectivity, and for which species? And if so, are there any diameter limits? And are there any length limit? Are wet and dry culverts equal? And are there any landscape considerations? So we set up a study with 269 pipe culverts in south and central Sweden. With automatic recording, we put our detectors on small rafts like this and pushed them into the tunnel. But since, you know, maybe some of you at least, that it's quite difficult to identify bat species by their sound when they are flying in the tunnel. So we combined this with some trapping as well. So we selected 73 pipe culverts with a high activity and continued with some trapping there. Okay, we found that there is a relation between the bat activity and the diameter size of the tunnels, and that bat activity is higher when there is water in the tunnel, and not surprisingly, because we are studying forest species, there were more activity in pipe culverts located in forests. This alternative here is with forest on one side and a corridor on the other side, a tree corridor on the other side. Okay, so this means that the probability to succeed with this culvert increase with increasing size. So for example, if we have the ambition to succeed in 80%, we should have pipe culverts of 3 meters, and so on. However, there are, of course, differences between the species. So if some species, like this one, the natterer's bat, it is very maneuverable. So it is able to use very, very small tunnels. So we had, for example, the smallest tunnels we studied was 80 centimeters, and we have that activity in these as well. And I could imagine that a species like Bechstein bat is also able to do that. So there are differences, but it depends a little bit which species do you really want to support here. So conclusions from this are that, yes, it works very well to connect habitat sites for forest species. And we identified Myotis branti, Myotis mustacinus, Myotis nattereri, Myotis dabentoni, and Plecotis auritus. And these are the most common forest living species in Sweden. So this was not a surprise. And pipe culverts of 80 centimeters are used, but the probability of use by bats increased with increasing diameter. There is no length limit. And we could conclude that there is higher activity in wet tunnels than in dry tunnels. And this is most probably explained by high abundance of the Daubenton's bat, Myotis daubentoni. And culverts in forest landscape are more used. However, we were not really satisfied with this because we want to know more about how bats are using these tunnels. Are there just occasional use the tunnel, or is it frequent use? Are they using it for foraging or for commuting, or how do they behave close to these tunnels? So we combined this with a radio tracking study close to some of these tunnels. We used Myotis branti, the Brandt's bat. And what you can see here is one, I will just present one site. This is north of the site, and this is south of the site. And we had two tunnels, one with water and one without water. This one is 130 centimeter, and this is about 2 meters. And we found that in this area, the bats using this area, they use the tunnel very, very frequently, all the time, many times every night, back and forth. And we had 3 hotspots here for foraging, and the road actually crossed directly these 3 hotspots. It's a forest-dominated landscape, so it's forest everywhere. But as you know, also in big forests, the resources are actually patchily distributed. So fragmentation is very relevant to discuss also if you have a forest-dominated landscape. And we saw that bats were, well, they were using other areas as well, but they used both these tunnels. So finally, I want you to meet our best friend, our most frequent new species, the pipe culvert bat. We named him Bosse. And you can see he has a radio transmitter, reflecting tape, and you can actually see how he behaved in the tunnel, first in real time. But that was maybe too fast, so I have a slow motion here as well. And what you can see, he is actually not only using the tunnel for commuting, but also for foraging, and he takes insects sitting there in the tunnel as well. So thank you very much for listening.
Thank you very much for informing us about the bats. And some questions?
Thank you for the information. Is it on? That's a good system. For the information, you talked about width, but not about height. It's the minimum height. Diameter. It was the diameter. So yeah. With this diameter. Okay.
Wens normale. we have lesser horseshoe bat in Ireland, and we've like they are clutter adapted bats as well, are they? Yeah, and we've seen them using 1 meter diameter pipes. Do you think if we actually increase the size of the diameter of those pipes that we get better use by lesser horseshoe bat, or is it based on individual bat activity?
There is a study of this, I think, but do you have also not only the lesser, but also Rhinolophus ferromicrinum maybe, because that one is bigger.
Yes, yeah.
Yeah.
Well, there has been noted sightings of it, that particular one. The lesser is more prevalent on the west coast of Ireland.
Yeah, okay.
Yeah.
Well, I guess if you, it is definitely clutter adapted, yes, and can use very small tunnels for sure. But if you increase, you will have other species as well, I guess. So, well, it depends on what objectives you have there.
Yeah.
And there are some others like Myotis. I guess you have Myotis nattereri as well in the area, and they use also the small tunnels. So,
right, yeah, yeah, yeah.
Yeah.
Okay. So it's basically the wider the diameter, the greater the diameter, the better use of.
But the good thing with these tunnels is also that you can actually you can build them afterwards to restore the area as well. So it's quite simple and not so expensive. So I think that's a good idea to check where you can improve the connectivity for maybe for all species.
Okay. Thank you.
Well, Jaanus from Estonia. It's nice to see that bats can use also the water culverts, not specifically designed for wildlife. And because for these animals that walk on the ground, we had some try this walking paths in culverts or so. But seemingly bats don't need this and can use this. Also, this culverts that are meant only for the water flowing through. Can you recommend something that we should considering when planning some new road or railway? What to say to the engineers about this typical water culverts to make them more accessible for bats? Except this diameter that is clear now, but is there something more to consider to make?
First, we have to remember that these tunnels are for the clutter adapted bats, so you have other problems with other species. So maybe this is not the only solution. And then, well, my recommendation is, well, as you say, we can combine this drainage function with bat activity. So that's very good news, I think. And the larger tunnel, the better. And then the placement, of course, is important. So there should be tree lines or forests very close by this tunnel. And yeah.
And surrounding landscape is important.
Yes, yes. But that is also something you can do afterwards, of course, if you want to improve the site to build a tree line or plant trees close by.
What about the shape of the opening, square or round?
Oh, I don't know. I have no idea. I don't think that matters at all.
Okay.
I don't think so.
But how open is the close surrounding of the end of the tunnels? Should there be some trees or bushes very close to?
Yeah, it's good, but of course, this is always a compromise because of road safety and other things. But
thank you.
Yeah.
Maybe last question, and if not, then I will ask colleague to start presentation of last presenter, who is Paula Reason, but it will come online or from computer. She's not present, but maybe later she can
Hi, I'm Paula Reason from RSK by Sense.
Respond or like answer some of your questions.
Hi, I'm Pallarisa from RSK Biocensus, and I'm here to talk to you about bats are protected against deliberate disturbance, particularly during the periods of breeding, rearing, hibernation and migration under the Habitats Directive Article 12. While this is at the level of the species, not individuals, local legislation in some countries can set a lower bar, for example, protecting against disturbance of individuals within their roost. But noise disturbance is poorly understood, so it's often lumped in with light and human disturbance. Bats have, of course, evolved in very noisy environments. They're echolocating and exposed to their own sound and that of their neighbouring bats. And those sound levels can be very high, typically 110 decibels in their immediate vicinity. So do we need to worry about noise impacts on bats? Well, we don't really know how and why, but just as we do visually, bats continually monitor their environment and develop a dynamic acoustic picture of what's normal, different, or possibly threatening. So yes, we do need to worry, but hearing a sound is not the same as being disturbed by it. As well as affecting bats in their roost, noise disturbance may affect the way bats forage, and the mechanisms for that include overlapping with the sounds bats use to detect prey, kind of acoustic masking, or competing with what bat is doing so that it can give less attention to prey capture, or a bat might simply avoid areas that it perceives as noisy, which might prevent it accessing optimal foraging areas. We've been handicapped because we don't have much data available to us. What we've tended to have is noise which has been measured for human receptors, so only up to 20 kilohertz, and A-weighted, so designed to emphasize those sounds which are relevant to humans, which underplays those frequencies that bats can hear and emphasizes sounds which bats may not be able to hear. What we need to measure is noise that is unweighted and measured from 5 kilohertz or less to perhaps 40 kilohertz. This is an audiogram which shows what bats can hear. There's a human on the left and 4 bat species on the right. They don't all hear the same, which means the species are different, but they all show that same shape, which means a louder noise is required to evoke a response at the highest and lowest frequencies, which might be important when we're looking at impact assessment. Where do we start? What noises do bats have in their natural environment? A colleague acoustician went out and measured levels of 40 decibels or more out in the countryside from gently rustling reeds, which produces similar noise to prey rustling. He was getting about 50 decibels in the relevant frequency range. So if we applied the precautionary principle, we could think that non-natural, unfamiliar or unpredictable noise exceeding 50 decibels maximum at 8-ish kilohertz within a roost could begin to have deleterious effects. So not roost abandonment, but more subtle effects such as increased stress. But that doesn't mean that disturbance should be considered significant as soon as construction noise exceeds that level, nor should we use that as a blanket threshold for disturbance, because much depends on other factors. So the factors you might want to consider are tolerance to noise. That will almost certainly differ between species, some of which are very anthropogenic, some of which avoid humans, gender and behaviours. So a breeding female, for example, will be particularly vulnerable to disturbance. But the baseline conditions will indicate the existing levels of tolerance. We know we have bats in motorway bridges and railway tunnels. A species' roosting behaviour and range size might also influence the severity of any impact. So something which is very faithful to its roost might be more greatly impacted than something that moves roost very frequently. When we're doing the work and how long we're doing a particular task might influence the severity of any impact, as it overlaps with different aspects of a bat's life cycle, and different construction activities produce different sound characters, so that also needs to be taken into account. For example, there may be an element of habituation, as we talked about for the railway tunnels. If bats are significantly impacted, they might abandon their roost or avoid optimal foraging areas. And of course, when we're looking at those sorts of impacts, we need to think about contributory factors such as lighting and human disturbance. Until recently, we haven't had much data on noise levels, but I was lucky enough to be working on HS2, who provided data on different construction activities. This example is for a chainsaw measured at different distances from source. Along the x-axis are different frequencies, very finely divided, and along the y-axis is decibels. You can see there's a particular pattern of noise. The further you get away, the more quickly the noise drops off, and particularly more steeply for the higher frequencies. If we do decide from our assessment that we need noise mitigation, we need to make sure it's well targeted so it's effective and use it where it's needed. The options are managing the times during which noise is produced, so avoiding the more sensitive times of year, locating noise generating activities away from receptors such as reefs, which is easier said than done when you're, say, piling in a particular location, reducing the noise at source by acoustic barriers or using different types of plant which are quieter, or protecting the receptor, or such as a reef, with barriers, although that can be difficult and is often not very effective when you have reefs, say, in trees which are very high. You can also compensate for lack of access to resources where this is predicted by providing additional roost areas or foraging areas. That was a very quick run through a complicated subject, but there is more information and guidance in the UK bat mitigation guidelines, and I have provided a link there. If you look at case study 38, you'll see that there is data for many different construction activities, similar to the one I've already shown you. And in Appendix 5, you'll see a template and some worked examples of noise disturbance assessments to make sure that we do the assessment right and target our mitigation where it's needed. If you have measurements that would be available to put in the next version of the bat mitigation guidelines, I'd be very happy to hear from you.
Thank you very much, Paula. And maybe, yes, if you have some questions, let's try to ask and we will see if it's working, or we can let it for later for, let's say, mobile email communication. But you are asking.
Can you hear me? Okay. Yes.
Yes, I can.
Yes. I have two comments. First, it's of course there are differences between the species. Can you develop that a little bit more? And the second is, I think this is complicated because I guess that with the noise we have long-term effects. I mean, if you study noise impact, you can see that bats that used to forage there before the road was built, they continue to forage there. But after the road is built, but then 10 years later, it could be different. Do you have any comment on that?
Yes, so the differences between the species are difficult because we don't have many audiograms between different species. So the four that I showed you, the ones that are available from the States, if we're making generalizations, one might assume that those bats which are adapted for passive listening, so they listen for their prey and go and catch their prey in that way, may be more sensitive to lower sound levels than those bats which go out and echolocate. And you could look at them in terms of their foraging strategy as well. So as determined by their echolocation strategy. So if they are quiet callers, they're obviously used to listening to quieter noises, whereas those bats which shout more loudly and fly out in the open might have different hearing thresholds, higher hearing thresholds. In terms of long-term data, we haven't really looked to see whether noise is a component of how bats adapt to using an area or adapt to use areas away from something like a road. But I'm finding more and more examples of bats in what you might think of as strange situations. So I mentioned motorway tunnels, I mentioned railway tunnels and bridges. I've also just found a common pipistrelle maternity roost in an electricity substation. I'm actually sending out acousticians to go and measure that next month, and they've clearly got habituated to that kind of predictable noise. So I think maybe the character of sound and the predictability of sound is going to be having an impact that could become incorporated into the bat's understanding of their landscape as something which is normal. So the jury's still out. But if anyone is interested in bats and how they adapt to noise and noise measurements, I'm really, really happy to get in touch with them and have an ongoing discussion, because it's not something we've thought about much in the past.
Thank you, but we have bit problems with the echoes in the room where we are listening. So I will ask colleagues who are interested, really try to ask later via email or something. Thank you.
Okay.
And thank you all of the audience. You come, you listen, you ask, and thank you very much all your presenters. Thank you.